All right, I'm here to try to talk to you about imaginary numbers. Now, imaginary numbers are basically our way of recognizing the fact that you cannot ever take the square root of a negative number. But we don't want to just stop everything we're doing and say, it doesn't exist, it doesn't have any value. We'd like to at least clean up our problem, whatever. So what we're going to do, and continue with our problem, so what we're going to do is we're going to pretend that we could take the square root of a negative number and assign it a variable so that we can continue with our problem and move on. Because we're using our imagination, they decided to call these imaginary numbers, which they really are. They're imaginary because they don't exist. No matter what, even after this lesson, you still cannot take the square root of a negative number. But we're just going to pretend we could. So what we're going to do is use the letter I. It's a lowercase italicized I. It's got a little curl to it. And it just stands for an imaginary value. It's your most basic square root of -1. Now, if I happen to square both of these, and I just wanted to look at what would happen if I had an I squared, I would basically be taking a square root of -1 and squaring it. Well, a square of a square root cancels out. So all that leaves me with is -1. So this actually has a value of -1. We're going to come back to that later, but hold that thought. Why do we do this? Well, let's say I asked you to simplify the square root of -49. Well, let's see what we have. Remember, when you simplify a radical, you break it down into all its factors. So 49 is 7 times 7, but -49 is 7 times 7 times -1. And we'll take out what we can. So a square root means we're looking for two of a kind. So I cancel out the two 7s, write it once on the outside. I have left a -1, and a square root of -1 is equal to I. So I cancel out my square root of -1, and I write an I on the outside. My final answer, since nothing is left under the radical, is 7I. Let's try another one. Square root of -28 would be -1 times, and 28 is 7 times 4, but I can break down the 4 and get 2 times 2. So, again, I'm looking for two of a kind, and I have a pair of 2's. So I could write the 2 on the outside. And I can't do anything with the 7, it doesn't have a match. But I do have a -1, and whenever you see a square root of -1, you can cross it off and write an I on the outside. So what's left? I have a 2I on the outside, and I still have a square root of 7. This is almost identical to what we did last semester with simplifying radicals. It's just that now we have that I in there that we have to take care of. All right. Sidebar, I want to talk to you real quick about additive inverse. What is an additive inverse? Basically, you ask yourself, what would add to make 0? So the additive inverse of 5 would be -5. The additive inverse of 2x would be -2x. So let's raise that bar just a little bit and try something really weird and different looking. 5 plus 3i. I'll explain this setup in just a few minutes, but right now just focus on additive inverse. What would add to 5 to give me 0? -5. What would add to 3i to give me 0? A -3i. Did you notice that really you have the same thing, but you have the signs changed? That became negative, that became negative. Okay, what about, pardon me, 6 minus 2i? Well, what would add to 6? -6. What would add to a -2i? A +2i. What about if I did something like -8i? What would add to that to give me 0? +8i. Pretty simple. Don't make it too complicated. Just change both signs. Unless there's only one term, then you just change that one sign. -9 plus I. Well, the additive inverse would be positive 9 minus I. That's simple. All right, now these are kind of weird looking. We haven't really talked about that, so I want to bring that up next. Those are called complex numbers. Complex numbers are where we take all of the real numbers. The real numbers are the numbers we already know. 2, 7x, well, 2, 7, negative 5, 2.1, 6 square roots of 8. I don't like that. That's not reduced. 6 square roots of 7. But all the numbers that we know, and we could actually find on a number line, are the real numbers. But I is imaginary. It's not real. It doesn't exist. So if we put them all together, the real and the imaginary, we have complex numbers. Okay, how do you write complex numbers? Complex numbers are always written A plus BI. There's two parts to that. Number one, the A stands for the real value. The BI stands for the imaginary value. The second thing you need to keep in mind is you notice that I said that the square root of -1, we're going to kind of replace it with a variable. And the point I want to make in what I'm doing now is that you're going to treat it just like any other variable, with one exception. I would never write 5 plus 2x. I would write 2x plus 5. Well, the real number always beats out the imaginary. So that's why this I will always be second. The only time it would be first is if there was no real number there. So you can see over here I wrote 3 plus 5i. The I is always in the second term. Okay, so let's talk about operations on complex numbers. Operations are addition, subtraction, multiplication. We're not going to talk about division just yet. Let's start with an addition. Now, if you notice, every one of these problems has 2 sets of parentheses. You have to be very careful to look what's in between. Okay, 'cause it's very easy to just assume, and we don't want to do that. These 2 parentheses have a plus sign between. So this is an addition problem. This is a subtraction problem. And this has nothing, which means it's a multiplication. So we're going to handle them slightly different. An addition problem, all you do is add like terms. You've done this. We did this all the time. Whenever you had an x and you just had to add like terms, that's what we're going to do. So what I kind of did here was I did a little rearranging. I put, oh, where did I put the green marker? Oh, well, I'll have to use a different color. I'll use the red. 3 gets added to the 6 because those are like terms. 5i gets added to the -2i because they're like terms. So I just kind of wrote them in that order. You don't have to do this if you don't want, but I kind of did it to help you see. The 3 plus the 6 gives me 9, and the 5i minus the 2i gives me a positive 3i. So, there's my answer. I cannot put these together and get 12i because they are not like terms, so I am done. You can see that. All right, let's try the subtraction. I have one little thing you have to be careful of with subtraction. Subtraction, you have to first distribute the minus sign. So let's do that. I have a 7 plus a 3i minus the 4, and then minus the -9i. You have to be very careful that that minus sign goes to both the 4 and the -9i. And what's minus a negative? Plus a positive. So let's make it plus a positive. Now, if you want, you can rearrange them. The 7 has a like term with the -4, and the 3i and a plus 9i, those are like terms. So you might be able to see it a little better. 7 minus 4 is 3. 3i plus 9i is 12i. And we're done with that one. All right, now let's multiply. When you multiply, when you have 2 parentheses, your main concept is you need to distribute. I'm distributing the 5 to each of these terms and the 4i to each of these terms. There's an acronym that helps us remember how to do this, and it would be FOIL. First, outer, inner, last. So what I'm going to do is use FOIL. 5 times the 6 is 30. 5 times the negative 7i is a negative 35i. The inner terms, that's the 4i times the 6, gives me 24i. And here's where you have to be careful. Probably the most missed part of this problem would be 4i times the negative 7i, which is a negative 28, careful, I squared. A lot of people forget that squared. Well, I see like terms. So I have a 30, negative 35i plus 24i is a negative 11i. And I have a minus 28i squared. You would think you were done, but you're not. Because, we talked about this a little earlier, we already know that I squared has a value. It is equal to a negative 1. So I should never leave. For example, you wouldn't leave in your answer 7 squared. You would square it and get 49. You would never leave the square root of 28 because you can still simplify it and break it down. You're not done yet. So I have an I squared. I'm not done yet. This is 30 minus 11i minus 28 times negative 1. Uh-oh. I better hurry. Negative 28 times negative 1 is a positive 28. And I have two like terms I can add. 30 and 28 is 58. Minus 11i is my final answer. All right? Just in time before you come walking in and see me. All right, good luck.